Hello everyone, welcome back to our 30-hour Python complete course for beginner. Welcome back to our 30-hour Python complete course for beginner. In the previous video, we learned about the return statement in Python functions. We understood how the function can return a value and how that returned value can be stored and used later in program. In today's video, we are going to learn another important topic related to the Python function. The topic is recursion in Python. In today's video, we will learn what is recursion function, how recursion works, base case, recursive case, countdown using recursion, factorial using recursion, sum of natural numbers, Fibonacci series, recursion versus loop, advantages and disadvantages of recursion, and some questions. And open my notes. Function done. This is recursion. Recursion is a programming technique in which a function calls itself. In simple word, when a function calls itself again and again to solve a problem, it is called recursion. For example, now it's to choose the next def show and show. In this example, the function show calls itself. However, this program has a problem. The function will continue calling itself without stopping. Therefore, every recursive function needs a condition that tells the function when to stop. The stopping condition is called base case. Now, what is recursive function? Now read first what I'm telling you. What is recursion? Recursion is program technique in which a function call. Now read this. Now here we see here recursion is a function which calls itself. It is used to directly use a mathematical formula as a function. For example, factorial n is equal to n into factorial n minus 1. Now, what is recursive function? A function that calls itself is called a recursive function. For example, def countdown number Here countdown number -1 calls the same function again. Therefore, countdown is a recursive function, but this function does not have a stopping condition, so it will continue calling itself. To solve this problem, we need a base case. Now, important part of base case. Important parts of recursion. A recursion function generally contains two important part. First one is base case and second one is recursive case. Okay. Base case and recursive case. Let us understand both. Base case, right? The base case is the condition that stop the recursive function. For example of base case, if number return when the value becomes 0, the function stops. Now next one is recursive case. Recursive case. This one is base case. And this, the recursive case is the part where the condition calls itself. For example, this one is the example of recursive case. The function calls itself with a smaller value. Now take 2 minutes. Now let's read this. Take 2 minutes. The next, read this. Here for factorial n is equal to n into factorial. The function can be defined as follow: def factorial n if I double equal to 0, or I Here base condition which does not here base condition which does not call the function any further return, then else return n factorial n minus 1 function call itself. This works as flow factorial for function called here 4 into factorial 3, 4 into square bracket factorial is then 3 into factorial 2, 4 into 3 into square bracket 2 into factorial 1, 4 into 3 into 2 into 1 function returned. Four into three into two into one. Here in the next now basic structure of a recursive function. Def uh, def function name value if stopping condition function name smaller the function check this topic condition. If the condition is true, the function stops, otherwise the function calls itself again. Now countdown using recursion. Let us create a program that display numbers 5 to 1. Here we write def countdown number if number return print number countdown number now see the output 5 4 3 2 1. First we call countdown 5. The value of number is equal to 5. The condition is if number is true is equal to 0. The condition is false because 5 is not equal to 0. Therefore Python prints 5. Then the function called itself countdown 5 minus 1. This will come countdown 4. The same process happen again. The function prints 4 and then countdown 3, then countdown 2, then countdown 1, finally countdown 0. Now the condition becomes true if number double equal to 0, return the function stop. Why do we decrease the number? In the recursive cell, countdown number minus 1 decreased by value 1. The value changed like this 5 4 3 2 1 and having 0. Therefore the function stop. If we do not decrease the value, the function may continue calling itself. Now countdown in reverse order. Def count up. Here we write up number return count Mhm. Count up number minus 1, print number, and the count up 5. Count up 5. Now see the output and count here underscore. Now see the output. 1, 2, 3, 4 and 5. The position of the print statement changes the output. The previous print the previous example print was before the recursive cell. In this example print is after the recursive code. Now understanding the order. Def count up number. If number double equal to 0, return count up, then number minus 1, print. The function calls happen in this order: count up 3, count up 2, count up 1, count up 0. A 0, the function stop calling itself, then the print statement executes while the function calls return 1, 2 and 3. Now next topic is factor using recursion. Now let us understand one of the most common example of recursion. The factorial of a positive integer is calculated by multiplying the number by all positive integer before it. For example I am writing here 5. 5 factorial symbol is equal to 5 into now for factorial 4 into 3 into 24. The factorial of 0 is a 0 factorial is equal to 1. Now factorial program using recursion. Def here def factorial if number In the next result, factorial result, factorial 120, factorial factorial 5, the function return 5 into factorial 4, then 4 into factorial 3, then 3 into factorial 1, 1 into factorial 0 is equal to 1. Therefore 1 into 1 is equal to 1, 2 into 1 is equal to 2, 3 into 2 is equal to 6, 4 into 6 is equal to 24, 5 5 into 24 is equal to 120. Then the final answer is 120. Now why the base case important? In the factorial program, if number double equal to 0, this is base case. When the number becomes 0, this is base case. When the number becomes 0, the function stop calling itself. Without the base case, the function would continue calling itself and the program would generate an error. Therefore, every recursive function should have a proper base case. Take 2 minutes to read this. Now in the next count up number. In the next def factorial n in the next difference between recursion, a function calls itself loop, a block of code repeat using a recursion use a base case loop. Loops are conditioned to range to stop. Recursion can be easier to understand for some problem. Loops are advantages of recursion. First one is simple code. Second one is useful for repeating program, useful for mathematical program, useful for tree like structure. The programmer need to be extremely sorry. Now disadvantages of recursion: more function calls. A recursive function may call itself many times. Can we use more memory? Can be slower. Some recursive solution may be slower than loop based solution. Requires a proper base case. If the base case is missing or incorrect, the function may not stop correctly. Now important rules of recursion. Remember these important points. A recursive function calls itself. Every recursive function needs a base case. the base case stop the function, the recursive call should move toward the base case. A missing base case can be cause an error. Now I have some practice question for you. Create a recursive function that prints from 10 to 1. Question 2. Create a recursive. Question 2. Create a recursive function that prints from numbers 1 to 10. Question 3. Create a recursive function to find the factorial of a number. Create a recursive function to find the sum of natural numbers. And question 5. Create a recursive function to calculate the square of a number. Now question 6. Create a recursive function to print the Fibonacci series. Explain the difference between base case and recursive function. Explain the difference between recursion and a loop. What happens if recursive function does not have a base case? Now next question, create a recursive function that calculates the sum of number 1 to n. You have successfully learned the basic of recursion in Python. If you found this video helpful, please like, share and subscribe to the channel. Also press the notification bell so you don't miss the upcoming videos in our 30-hour Python complete course for beginner. Thank you so much for watching the video. Thank you for watching the video.